One of the most common questions we get from customers is, what CAN bitrate should I use? And the honest answer is, it really depends. In this video, we'll explain what CAN bitrate actually means, why it matters, and how to choose the right bitrate for your system. So what is the right CAN bitrate? Let's start with the basics. CAN bitrate is simply how fast data is transmitted on the CAN bus. It's measured in kilobits per second. Typical values you'll see include 125 kilobits per second, 250, 500 and 1 megabit per second. One important rule to remember is that every device on the CAN network must be configured to the same bitrate. If even one node is different, communication will fail. Choosing the wrong bitrate can lead to a range of issues, including communication errors, unstable networks, or devices repeatedly going bus off. It's also important to understand that bitrate isn't just about speed. It directly affects signal quality, network reliability, and how long your CAN cable can be. One of the most important relationships in CAN networking is this: the higher the bitrate, the shorter the maximum cable length. For example, at 1 megabit per second, you're typically limited to around 40 meters of cable. At 500 kilobits per second, this increases to roughly 100 meters. And at 250 kilobits per second, cable lengths of 250 meters or more are common. This comes down to signal propagation delay. CAN relies on precise timing, and the signal needs to travel across the network and back within a single bit time. So how does this work in practice? In automotive applications, many CAN networks run at 500 kilobits per second. This offers a good balance between speed and robustness. In industrial, off-highway or mobile machinery, 250 kilobits per second is often used, especially where cable runs are longer and electrical noise is higher. For diagnostics, body electronics or simpler networks, 125 kilobits per second is common, where reliability is more important than data throughput. But bitrate isn't the whole story. CAN communication also relies on bit timing parameters, such as the sample point and time segments. In most cases, CAN interfaces handle this automatically. However, when you're dealing with long cable lengths, high node counts or marginal signal quality, adjusting the sample point can make a big difference to network stability. This is where having the right tools matters. Being able to measure and analyze the bus allows you to optimize the network instead of relying on guesswork. If you remember nothing else, remember this: all devices on the same network must use the same bit rate. Use the lowest bit rate that meets your bandwidth needs. Longer cable lengths generally require lower bit rates. If you're unsure, measure the bus rather than assuming. If you're unsure what bitrate your system should be using, or you're experiencing CAN errors that don't seem to make sense, that's exactly the kind of problem we help customers solve every day. Follow us for more practical CAN and vehicle networking tips from engineers who work with these systems in the real world. And remember, we also supply a wide range of CAN and vehicle networking hardware through our web shop over at controltech.uk.com. That covers diagnostics, interfaces, gateways and logging tools as well.